Hi everybody, I'm Rob. This is Mike. I don't know if you caught Mike's session earlier today about the Couchbase Operator. We're going to touch on some of that, but also talk about operator basics and how this can help you automate applications that you're running. This is going to be in the context of OpenShift. You'll see a lot of OpenShift logos here, but this is all just Kubernetes primitives that we're going to be talking about today. And so what we're going to talk about is basically this idea that you see on the screen here, which is you have a really complex distributed application running on top of Kubernetes, in this case Couchbase, and there's a bunch of unique knowledge that's needed to run that application, from how it's installed, how it's configured, how you migrate between versions, how it's failed over, how it's scaled up, how it's scaled down. All these things just are that unique operational knowledge to run a very specific application. And today we're going to talk about how you can embed that into some software called an operator, which allows you to then very easily package and install this out on a number of different clusters. In this case, it could be a number of different sites that you have around the world. It could be, I want to run on every cloud provider, for example. I want to do failover between regions. I want to deploy this at all of my customer sites, whatever it is. You can put that operational knowledge into a piece of software such that you don't have to be an expert at how Couchbase is failed over, for example. Mike has built that into the operator so that you don't have to be as in-depth about that. You do need to know some high-level architecture, just like you're going to care for any application that you're running. And so to do this, we have an open source framework called the Operator Framework. And this encapsulates a number of the things that you need to do to build an operator. Now, an operator is really something that is glue between your application and an orchestration platform, in this case Kubernetes, to manage and package that Kubernetes application. There are a number of these out in the wild that we're going to talk about a little bit later on. But here you can see, for example, there's a Prometheus and an etcd operator that we both worked on at Red Hat. And operators are really, really exciting because they give you this Kubernetes-native extensibility. And what that means is you want to go and take your application and you want to plug it into the environment where your engineers, your teams are going to find services. This might be a public cloud provider, for example, but maybe instead of just taking an off-the-shelf database, you have a very specific way that wants to be run. Or you have a very specific queue that you like to use and you want to standardize that against all your teams. And so you say, wouldn't it be great if I could just plug that specialized thing into my public cloud? Well, you can't just take some very opinionated install and just say, hey, can I have it show up in the Amazon dropdown, just like RDS and all the other services that they have? You can't do that. They only allow their services to be there. The great thing about Kubernetes is you can actually do this. Kubernetes has a number of extension mechanisms such that you can say, I want to make a new top-level object in Kubernetes called a Couchbase cluster, and then have that work just like anything else. So you can scale it, you can get the health of it, you can track it, you can reconfigure it. All these things all native to the Kubernetes command lines. It's automatically inserted into the API. So it's really, really great experience, and an operator is the way that you can do that. Another really great thing that an operator gets you is a really easy hybrid cloud story. Either if you're a software vendor and you want to be supported on all the major cloud providers, or you built a piece of custom software in-house that you want to deploy across a number of different providers or a number of co-location centers, whatever it is, if you're running Kubernetes and programming against that, you have that extraction layer from your infrastructure. So we've talked a little bit at a very high level about an operator, but if I was going to actually write one of these things, what does it actually do? So it's really a set of a manifest, which talks about the configuration of a specific instance of a Couchbase cluster, for example. And you need to translate that into something that actually gets run on the cluster. This is generate all the configuration files and all the secrets and start these application pods. Whatever it is that needs to be done in the Kubernetes land, the operator sits in the middle there and is the smart brains that makes that happen. And it's really powered off of this kind of desired state control loop where you're looking at the current state of the cluster. You're analyzing what needs to change. That's either things that a human operator has said I want to scale this from 2 to 3, or I want to change it from this version to that version, or I want to back it up now, for example. Analyzing what's the difference between what's currently happening, what the desired state is, and then acting on that. And you can do that really, really fast because this is a computer. You can do this in milliseconds. And so this really follows the best practices of modern distributed systems. So a lot of them in the container world today are very declarative. This is very nice because you don't care what state the system is in. You just want it to end up in the state that you desire. And what you can also get out of this is the native extension point for Kubernetes works in this way, where you've got this loop that's constantly running. This is how Kubernetes works internally. And so you can plug in your own logic into this, which is why it makes a really great platform to run something like Couchbase and these really stateful, complex applications. And another thing where we've used this to great effect at CoreOS and Red Hat is as an enabler for over-the-air updates. So if you can start a new version of an operator on a cluster, you can actually then seamlessly upgrade all the instances that operator is looking after. So if you've got, say, 10 staging environments, a QA environment, some other staging environment, and then a production environment, you can have something seamlessly upgrade all those environments with all their unique configuration and move that from version A to version B. Like most distributed systems, you can do that in a seamless way. Because you have all the right primitives at the cluster level to route traffic around and do scaling and failover and restart this in this order, that type of stuff. So this is what you get from Kubernetes. You have all these tools, like I was just talking about, in your toolbox to orchestrate with your operator. So you get load balancing out of the box, doing things like TLS termination and ingress and traffic handling, service discovery, auto scaling, secret handling. All these things that are pretty hard if you're just going to show up to a customer site with a pile of VMs and say, hey, I want to have this database running. You don't have any of these tools. You got to hope you have an extra load balancer for me, or we're doing DNS, or let's install a console server or whatever for service discovery. You have all this built in with Kubernetes, and if you target that layer, these aren't problems that your company has to solve. You're not an expert at that. You're an expert at running a database or running your software, or whatever it is. Inside of our operator framework, we have a kind of a second tier of tools that help you do things like I said, running multiple instances of these applications and upgrading them, doing license enforcement. If you want to do some metering and tracking of different types of metrics, that's a very easy thing that we have built in. Resource allocation and controlling limits and hard limits and soft limits and that type of stuff. And then some testing tools where this is going to be a very autonomous piece of code that's running, and so you want to make sure it's really good, because if it just starts killing off all of your application instances when it shouldn't be, that's going to cause downtime. You're going to lose all your nines. Not good. And this is a really great, simple example of what one of these looks like. The extension mechanism in Kubernetes that is being used to make one of these is called a custom resource definition. This is what it sounds like. You're putting a custom resource into the cluster, like a Couchbase cluster as an object type. In this case, it's an etcd cluster. And you need to define it, hence the CRD. And so what we're looking at, this is a Kubernetes object. If y'all are familiar with Kubernetes, this looks very familiar to you. It has this metadata block where you give it a name. And then this spec block is just all the custom specification that our operator knows what to do with. We're going to look at an example of a Couchbase one in a second. And it has a lot more options than this because it's really powerful. But here you have the size of 3. etcd is a quorum-based system, so you need an odd number of instances. So this would be 3, 5, 7, 9. And then a specific version. If you wanted to upgrade from version 3.2.13 to .14, you would change that, hit save, and the operator will go upgrade that with all the instances kind of revved one by one. What's great about the operators is this concept has really taken off. There's a number of these operators available today, and folks are building more and more every day. We have a GitHub repo of awesome operators. If you'd like to browse a list, I think there's like 60 or 90 of them on there at this point. And you'll see that they represent a lot of stateful services and things that are really complex. So if you're familiar with failing over Postgres, for example, it's like It's a not easy thing, but it's a figured out thing. It can be codified into a set of steps. But instead of following a run book to do that every time, at 3 a.m., why not write some software to do it and have it happen automatically? Then you'll wake up the next day and say, oh, hey, we failed over. Failing over is not like a crazy thing anymore, just like rebooting a server shouldn't be a crazy thing anymore. And then if you're familiar with things like HashiCorp Vault, this is a really important service because it's storing your secrets. You want to make sure that it maintains its quorum. It needs to be unsealed, and data needs to be written very securely. You don't want this to be done in an insecure fashion, especially if you mess up some configuration. You can include a bunch of checks into the operator to make sure that that doesn't happen. Those are all open source kind of community operators. And there's a number of folks that are also offering their operators commercially. And so Couchbase is one of the ones that has been doing this for a very long time. So it's great to see it reach a high level of maturity. There's a number of other folks here. So companies are getting behind this too and distributing their software in this manner so that you can go to a customer site and say, hey, let's get the Dynatrace agent up and running. Boom, install the operator, good to go. Running like Crunchy Data's enterprise Postgres. Same thing, it does a bunch of backup and failover and all these things that you would expect from a cloud service, but it's running on your infrastructure, on your Kubernetes cluster. It's really great and very, very cool. And so we're working with a number of these folks to help them architect their operators and use their SDK to make it even more powerful. Here's an example of what the Couchbase operator looks like on top of an OpenShift cluster. You can see in the markdown here, there's a number of the supported features. It's really cool. We're going to do a live demo of this in a second. But you get this really, really fast automated provisioning, doing all of the scaling and auto recovery that you would expect from a cloud service, all running on software that you control. These can be fully offline clusters, things that you can't get from a cloud provider. And I mentioned we're going to take a look at one of the Couchbase cluster objects. This is what it looks like, and it keeps going off the screen for a little bit. But this represents all the things that you're probably familiar with for tuning your Couchbase clusters. You can see a number of stanzas there and a bunch of kind of the default values. And this is how you can reconfigure your clusters either on demand if you want to do this in a CI system and wanted to kick one of these off for every pull request, for example. Or have different environments for dev and staging and prod, or different settings and different prod for different customers. Whatever you want to do, however you run your clusters, you can tune them in a very self-service way. So you just let your engineering teams run an operator, and then they can go to town just like they would go to Amazon and request a database, or go to Azure and request a database. This is the exact same experience. All right, let's go take a quick look at a demo. Ooh, my screen is going to be all messed up. All right.
I want to move the screen a little bit. It cuts.
Oh, yeah, it does cut off. Let's see if we can do that. Come on. Well, nav is not important. OK, so what we're looking at here is the screenshot I just showed you of a live OpenShift cluster, and we're looking at the Couchbase operator. And I've got one of these running already called example. And you can see here that we've got a few different Kubernetes objects. This is what the operator is actually generating. But let's make a new one so you can see how quickly this happens. We're going to call this example 2. So here's our default set of configuration. Let me see if I can make this a little bigger. And so we've got a number of different things set up here. You can see like our size equals 3. Let's bump it up to 5. Why not? So what we're going to do is create this, and our operator is going to read all of these settings, figure out what it needs to do, and then install a number of those the pods and services and set the configuration files, anything that it needs to do to successfully start our cluster. So here you can see that it is creating.
If you can zoom that just a little bit so we can see it a little better in the back, that would be great.
Sure.
Thanks.
All right, so we're going to look. So what this is doing is adding and booting. So we have 2 services. This is how we address the cluster. And then we've got one pod here that's running. It was created about less than a minute ago. And what this operator is going to do is slowly add these members and make sure that they come up to be healthy. And soon we'll have our 5-node Couchbase cluster. So there you can see that we added our second pod there, number 1. And this will keep going. And what would happen as well is once these are booted, if one of these pods happen to go away for some reason, if the node it was on died, for example, the operator is going to rebalance all of that data seamlessly for you and transition everything that you need to have a healthy cluster. And that would happen, whenever it needs to, without your any type of human involvement, running a run book, running a script, running a bash script, anything. The operator does it all. I don't know if you want to add in to any of the bootstrapping that's happening right now.
Yeah, so I think the one thing that I just add in is, we showed a lot of stuff with the operators, and this is something that's new from Red Hat. And so as operators are taking more and more hold in various places, people are writing all kinds of management stuff. If you were at my talk, I loaded this stuff in from files using kubectl. And we're really starting to get to the point where there are graphical interfaces that help you manage these operators specifically, manage their upgrades, and so forth. And so that's one of the things that I think is really cool about the stuff that Red Hat's doing.
Yeah. So as he mentioned, what we're trying to build into our Kubernetes offering, OpenShift, is lifecycle management so that you're not just running operators from Couchbase, but you've got a number of different ones for all of the dependencies and infrastructure building blocks that you have from databases and queues and web servers and other distributed systems. You can start constructing them together, and then in your applications just saying, hey, I need a Redis, I need a Couchbase, I need a Mongo, whatever it is, and just instantiate that, and you're good to go. And the operator's looking after that, so you're not an expert. You know that you need how you need to interface with that database, but you don't need to be watching all of the pull requests coming by and read the release notes really, really carefully. The operator's just going to, implement those new features for you, do it correctly, and then keep your software healthy.
And then just one other thing I wanted to add is one thing that I didn't show in my presentation was all the steps that you have to go through setting up security, various security settings to get something installed. And this takes care of that really nicely. You just click a button, it sets everything up for you. And I've found working with people that setting up the security stuff is a very error-prone process.
Yeah, and being a very enterprise-focused company with a long track record for security, we want to make sure that this is all done very correctly. And so you can set up a number of different rules that the operator can use to only interact with very specific objects that it needs to. So if you don't want the operator, if it doesn't need to create secrets, don't give it access to create secrets. We do all that for you automatically. We can go into more detail if we have a time at the end, but I'm going to jump back to the presentation. Come on. All right. We've seen a lot of success with some of our customers, and I wanted to share this quote from Ticketmaster. I think it's really great. That they use Prometheus operator. Prometheus is a container-native kind of cloud-native, I guess you could say, monitoring stack. And it really gets the fact that containers come and go very, very frequently. And you need to not monitor like a specific IP address, for example, because that IP is going to be changing constantly. So what you do is you configure like a label query, and you can then monitor a group of containers that are running. And if that group goes to 7 and then down to 5 and down to 3, it doesn't matter. And so what Ticketmaster does is they let all of their engineering teams just run their own monitoring infrastructure so they can tune how much retention they have, how much resources it has, and it just eats into their quota just like any other application. Here's 30 gigs of RAM for production, go run stuff. And so they're actually running 344 instances of Prometheus. And all these teams aren't experts at Prometheus nor monitoring telemetry time series databases, but they're able to tune the little bits that they need and say, I want to keep this data for 30 days or use at most 4 gigs of RAM, whatever. And the operator just does that, failing over, pulling data around, and monitoring the services that they want. And so each team has their application infrastructure, and you can't scale humans to run 344 copies of something. I mean, if you're running any sort of SaaS business, which they're not, but like that's a common skill, you have to automate these things. And so an operator is really the only way that you can operate this in any kind of scale, even internally. If you just wrote an application, just think about all the environments that you need to have across an enterprise to do things. So this is like a really great example of how an operator brought these teams into the tools that they want, getting them the scalability that they need without them having to be experts. So really quick, wanted to talk through how you make an operator through the operator framework. So there's a number of different pieces. We're going to talk about the SDK and the lifecycle manager today. So that's on the build side, and then there is the lifecycle side. That's on the deploy and upgrade side. So the SDK gets you a foundation to build with, and then you're really only bringing your application logic. So this is if you're running a database, it's how to scale it and fail it over, do whatever it needs to do, rebalance. And you have a number of tools to test that locally, test it on a live cluster. And when you're ready to publish that, you produce a manifest, which is kind of describes the application. And then you have the container itself. This is the operator that runs on the cluster. And what you do inside of that is you run that loop. That container is running, and it's looking at Kubernetes events coming in for like a node dying or something needs to be restarted. And then human-led things like I want to reconfigure this from 5 to 7 replicas, for example. And it's observing that and making it happen, and then outputs Kubernetes events on the other side. So the really great thing about the Operator SDK is this is kind of primarily focused on folks that want to distribute their operators to other companies, is that we're maximizing your opportunity to just bring your application logic and not have to worry about all of this complicated connection to the Kubernetes API and how do I watch this and how do I monitor that. All we do is say bring your logic and we can help you produce this operator in a very quick amount of time. And then when you need to give that to an end user to run, like you said, there's no security settings to mess with. You just give them the container image from your container registry and that manifest, and they're off and running. And then they can decide where that container needs to be hosted. And then the producer of that operator can decide if it wants to be open source or not. You have all the tools at your disposal. No one's forcing you to do anything. And so the lifecycle manager will be pre-installed in OpenShift, but it works against every Kubernetes environment. And what you do is you take that manifest and you load it into your catalog, and then all your namespaces, all your teams can then self-service boot Couchbase clusters all over the place and use their own cluster quota and all their resources accordingly, tune it accordingly, do everything that they want to do. There's a number of operator types and maturity scale that we've developed. This is where we're working with a lot of partners to get them all the way across this scale. And it roughly kind of coincides to what you would expect at the very end on level 5 with a cloud service. So it's doing automatic vertical and horizontal auto scaling, abnormal detection of different things internally in the application, scheduling, tuning, metrics, doing all that type of stuff. But you can really get really far with a number of different technologies for every cycle of this. And really the goal for this is to have something that works like a cloud service, but runs on any infrastructure. So you're just using Kubernetes itself. You're not tied to Amazon or Azure or Google or VMware. So you can move between all those environments. Remember that hybrid cloud story is really important. So to implement this, there are a number of different pieces of technology you can use. If anyone's familiar with Helm, which is a very popular tool in the Kubernetes ecosystem, that can get you into like phase 1 and phase 2, and is really great for stateless applications. So if you've got something that can really scale out up and down very easily, Helm is a great way to do that. Ansible, this is really great, especially if you're not in an operations or in a more operation-focused team versus like a traditional software development team. You can or reuse existing playbooks that you have. You can connect your Ansible playbooks to Kubernetes events. So when I install this thing, kick off the install playbook, and then when I scale it or scale up or scale down, kick off these playbooks, that type of thing. Really easy way to get into it. But then the cream of the crop is the Go SDK. This is using all the tools that are available to you from the Kubernetes ecosystem to build your operator. Insert any custom logic that you want. I think you could probably talk to how much logic it takes to do all this stuff correctly. But the beauty of it is he's building it in where you don't have to be randomly running all these scripts and doing all this failover. So it's really great. I think that's where you'll see a lot of the very complex applications go. Do you want to share any experiences with kind of getting through this maturity model as you were building the operator?
Yeah, so one that I'll touch on is kind of the getting started phase. So when we got started a year ago, so this was still really new. There was no operator SDK, and so we actually built all of the code that connects into the Kubernetes APIs to get all the events by hand. And it's certainly doable. It's not like incredibly complex, but it took us about a month to get it together to the point where we could really start adding in our own application code. And so what the guys at Red Hat have done is basically put together a project that allows you to scaffold all that code. So basically, whether I'm writing an operator for Couchbase, or you guys are writing one for etcd, or for whatever project it is, there's a big piece of code that is pretty much the same no matter what you're doing. And so some of the projects just help you get through getting all that stuff set up so that you can get going on the code that really matters to you. And so we eventually integrated with the project that they have. We already had a lot of this stuff set up. But had we started again, we absolutely would have used the Operator SDK framework.
Yeah, we're happy to take some code off your hands so you don't have to maintain it. All right, I think that is almost the end of my talk, other than these links. If you want to find more information about some of the code and these SDKs and get started with them, here's a few links. It's all under the Operator Framework GitHub organization, and there's a getting started guide, a number of things there. And I would encourage you, if you want to get started really quickly, the Helm Operator Kit to get you into phase 1 and phase 2 here. I wrote a blog post that you can find if you Google for it that will get you up and running in 15 minutes, so it's a really easy way to try it out. Sure. Thank you.
Rob, Michael, again, thank you very much. It's been tremendous. There's so much data to get through and information to get through to you in such a short period of time. Everything will be posted. You'll be able to review it again at your leisure. And obviously, take a look. Red Hat's done a whole lot of work here, and they're a great partner for ours to have. So thank you again for all the work.